So in Idaho this year, as the second warmest winter in the historical record, the warmest being 1934, we are missing our low elevation snow almost entirely. And our mid elevation snow, we maybe have about half of that across the state. So the big question is, what is the runoff out of the mountains going to look like when the snowpack melts? Hello, I'm David Hokema with the Idaho Department of Water Resources. I've been working here as a hydrologist for 12 years. So one of the big questions being asked to us this year is what is the runoff going to look like since we're missing the low elevation and a good portion of the mid elevation snowpack? If we divide snowpack roughly from 3,000 to 6,000 feet, we call that the low elevation snowpack. Somewhere in there, the snowpack typically begins in a normal year, and then the mid elevation is from 6,000 to 8,000 feet, and the high elevation, we consider that the high elevation snowpack is above 8,000 feet. So if you look at the Spokane Basin, which notice it's at it's 58% of normal in this graph from March 2. Um, it uh it is all low elevation snow. This year, that low elevation snow is almost entirely missing. There is a little bit of low elevation snow, but very little. And so this basin relies entirely on the low elevation snowpack. It has 1.3% mid and 0% high elevation snowpack. So when it comes to the August and October, we expect to see almost no bump in runoff in the Spokane Basin that typically would fill up reservoirs or be used for hydropower generation. We expect that to be very small, and then the base flows that are sustained by the higher elevation snowpack, that just isn't going to exist because this basin is mainly low elevation snow, and it typically carries snow all winter long. But in this extraordinarily warm winter, we have almost no snow in that basin. It's 58% of normal, and that's a little bit of a high estimate. It's it's probably under 50%. If you come over to the Boise and the Payette, which are a large source of irrigation, this graph in the middle represents how much water is diverted out of each of those basins as a total of the Snake River Basin outlined there in red. You'll notice that the Payette Basin is about 2.9% high elevation, 30% mid. So it has a decent upper elevation snowpack and a pretty good sized mid elevation snowpack. Some of that mid elevation snowpack is there, but we really expect this 71% represented on this map is overrepresented, and if you look at the snow course data, that will push this number down probably closer to 50%. If you look at the Boise Basin, again the same thing. It has a lot of mid-elevation snow, a chunk of high elevation snow, and since we're missing the 62% and a good chunk of the 29%, we do have some snowpack, but it's pretty limited. If you go over to the upper Snake, and if you look at these basins here, the Little Lost, Big Lost, Little Wood, they match the Snake pretty closely. But in the Snake River Basin, over 40% of that basin is high elevation snowpack. So it has a good solid snowpack throughout this region. And then it also has a pretty decent snowpack within the upper portion of the mid elevation. So most of the snowpack in the upper Snake is there. We may be missing 10% here, but in other, especially these mid elevation basins, we're probably overrepresenting the snowpack by 20 to 30%. And so what that does when you're missing that mid-elevation snowpack in these basins, you're not going to get that spike that we typically see at the end of May, beginning of June. On the Snake River, we should get a spike that will help fill up the reservoirs. It won't be as as large as typical, but it should still be pretty decent because we have a pretty good representation of snowpack there with the current monitoring network. It should be noted that the Snowtel network is typically really well correlated to runoff. Because this is such an extraordinarily warm winter, the Snowtel won't represent the snowpack except in the Upper Snake and the Big Lost areas. It won't represent it that well.